For this video, we are in the virtual desktop. We are going to be doing the Lab 5 for network analysis. And so we can come into here. We're going to go to Cadence Release. We're going to click it and go to Capture CIS. We're going to click OK for this Allegro. It's going to come up. We'll create a new project. We'll just title this Lab 5. And then we want PSpice analog, and we want this desktop location. We'll click OK once this is Lab 5, and we want to create on a blank project. So now this should load up, and we will have a blank project like this. Now we want our circuit to look like the following. And so looking at this, before we do anything, we're going to have to click this little ant looking thing at the top right. We're going to have to click the thing right next to the reload and the X, and these files are going to come up. I'm going to want to select all of these files, click open, and now we have all of the different parts here that we can use. We want to use a opamp. Now it can be a UA741 or I think an LA741. We have a UA opamp, so we're just going to use this one for this example. So we're going to get our opamp and we're going to place it in here. We can zoom in a little bit, press escape to get that away. And we have a positive over our negative, and we want that switch, so we're going to go in here and do mirror vertically. And so now our op-amp is going to look like this. Looking at the diagram, there's a couple of things that we can do initially. First, we're going to add our resistors, so we'll just type in R. We will just press enter, and then we will place our R1 right here, and we will place our R2, let's just say, up here. So those are our resistors. And now we need some voltage to the left of us, the far left. It's going to be a specific type of voltage. It's going to be Vsin. So typing that in for our part, we can press enter, and we have this part down here that we can place. We can then get a ground wire, because this has to be grounded. We're going to place the ground right here, and we're going to place the ground right here. And then we're going to connect these. So this will be connected, this will be connected, and this will be connected, and then this will be connected. Now in the lab, we have to measure these resistances actually in person, in real life. We have to measure them with a digital multimeter, and so our values are going to differ. It's not going to be exactly 1K, that's the exact value. We want the experimental value, not the theoretical value. So in here we're going to type 0.993, press enter. That's for our R1, and then this is for our R2. Again, I measured these values, so they can be different a little bit, but it should be close to 1,000 ohms. So that's what we're going to have here. Next, we first should have done the VCC, the positive and the negative. So we'll do that now. To do the VCC, we're going to do a VDC, so voltage DC. We're going to get two of them. We are going to place our first one right here, and then our next one right here. So we can see that looking right here, we have positive and negative VCC coming out of our op-amp. And so the top part is this negative. It's a V minus. So this VDC is going to have to be rotated, and so that the negative is facing the same way as the negative, like this. So when we connect it, it's going to be a negative negative, and then with here, it's going to be a positive positive, like this. And then we are going to have a ground. So we're going to click our ground to the right, and then we're going to place this here and place this here. We want to rotate this so it looks on the same line. Rotating both of these, it'll look like this, and now we can connect these. So this will be connected here, and this will be connected to our ground, and then this will be connected here, and this to our ground. So our voltages for these we measured as 3 volts and negative 3 volts. However, when we type it into this Cadence Release PSpice, we're just going to have 3 volts and 3 volts because we have this negative V right here that'll automatically take care of it for us. So we don't need to worry about making this negative. So this is going to be our voltage so far. We do have some output, and so we need to connect this across here, and then it's going to go across here and connect to this resistor, and this resistor is going to connect like this. And so this is what our op-amp is going to look like. It looks exactly as how we've had it on the actual lab report. So this is this. And now we need to change some of these values. So this is going to be 0 volts. This V amp is going to be 2 volts. And then the frequency is going to be 500 hertz. And this is all from the actual lab report that we've written up. So we'll move this over, and that is going to be our voltage. So after we do this, we are going to need to make some net aliases. We can go up to place, we can go to net alias, and then we're going to do V naught or VO. We'll press OK, and we want this to be our output line right here. So we can place this anywhere. I'll just place it right here. And then we also want a V1, so we're going to go place, net alias, V1, press OK, and then we have this V1 we can place on this line because this is our V1 voltage. And so this is what our circuit diagram will look like. This is it totally done. Now what we want to do is we want to go to PSpice and make a new simulation profile. We'll title it Lab 5 and click Create. A little window will pop up on the bottom, so we're going to have to go and open it. We want to click Allegro PSpice Simulator, click OK. Now we need to change the runtime and maximum step size. These are both in the lab. We were given a paragraph about it with the information that we use to actually create this circuit diagram. So creating this simulation setting, what we're going to do is we're going to look at the runtime. And for this lab, we need the runtime of t, that is the runtime time. T is between 0 and 3t. So 3t is the period, and the period is 1 over frequency. So we're basically going to have 3 times 1 over frequency, or 3 times 1 over 500, or 3 over 500. And then this is going to give us a result of 6 milliseconds. So in here, we'll just write out 6 ms for milliseconds. We'll go down to maximum step size, and from the previous lab, lab 4, we found the maximum step size to be the total runtime divided by the number of steps. Our number of steps is going to be 500 here. So we'll take our total runtime, 6 milliseconds, divided by 500. This is going to give us 12 microseconds. And so we can click Apply, click OK, and then click Run. That's going to come up, and then all of these values are going to pop up. We can move them, that way we can see where they're pointing to a little bit better. So just move them around like this, and then it will show off the graph a little bit better. Then you'd screenshot this and then include it in your lab report. Obviously probably rearrange these a little bit better. But that is how that's going to look like. Now we're going to move on to the graph. So we're going to click this schematic right here. If the schematic is black, it's better to see it in white. So to do that, you want to go to Tools, Options, and then Color Settings, and you want to change the background and click OK. Then from here, you want to click Plot, or I'm sorry, click Trace, click Add Trace, and you don't want currents or power, so uncheck those, and we just have voltage. We look through our voltages, we have this V, V naught. We'll click OK, and we can see that this V, V naught is placed. Now, let's right click this and click Trace Properties, make it a different color so it's easier to see. We'll do purple, and then you want to make the width a little bit bigger. Click OK, so it'll look like this. And then you want to plot another thing, so we'll go to Add Trace, sorry, not plot, Trace, and then Add Trace. And then you want to add the V1. So click OK, and we can see our V1 comes up. We'll right click this, Trace Property, change the color again, and change the width. So it'll look like this. And we can see our two separate lines. We have our V0 in purple and our V1 in the orange. And that is how you would do this lab.